Hi friends, welcome to GMK tutorials. In this video, we are going to see about the basic edge detection methods. Generally, if you want to identify the edge detection, that can be possible only changes in the intensity values. So that can be accomplished by using the first order and second order derivatives. Now, in this video, we are going to see about the first order derivatives. Okay, so for that purpose, image gradients and its properties. Okay, image gradients. Okay, so image gradients means that for finding the edge strength and the direction of the corresponding point, we use the image gradients. Generally, the image gradients is used to identify the strength as well as the corresponding values. So it can be represented as delta f for image gradient. Delta f is equal to notation that is equal to gradient of GRAD f. That is nothing but gradient of f is equal to, we can represent gx and gy. Okay, this is the notation where gx is nothing but gx is equal to dou f by dou x as well as gy is equal to dou f by dou y. Now, if you want to identify the edge, obviously you have to compare the corresponding pixel with the background pixel. If you want to compare the corresponding pixel value means that is the strength of the pixel. The strength of the pixel can be identified by using the gradient value, that is nothing but magnitude. So the magnitude of the gradient can be represented as m of x comma y is the magnitude of the gradient, that is equal to mag magnitude of delta f. That value gives rise to square root of gx square plus gy square. As well as if you want to identify the direction of the edge, this is the identifying the edge point. Obviously the edge is also moving different directions. So for identifying the edge direction, you have to calculate the angle, that is nothing but angle of alpha of x comma y is x comma y is the location of the corresponding edge point, that is equal to tan inverse of gy by gx. This is a notation for finding the angle of a corresponding edge. Okay, as well as the gradient operators means that obtaining the gradient of an image requires the partial derivatives. Suppose if you want to identify the gradients, you need a partial derivative, that is generally called as gradient operators. Suppose if you want to find out the gradient of an image, it requires a gradient operators. The gradient operators means that first order derivatives, that is nothing but gx is equal to dou f of x comma y by with respect to x. That gives rise to first order derivative. Therefore f of x plus 1, because of it is the x direction, f of x plus 1 y as well as f of x comma y. This is the first derivative. At the same time, gy is equal to, it's the y direction, that is equal to dou f of x comma y by dou y. So that gives rise to where x is a constant, y is a variable. Therefore, f of x comma is a constant, y plus 1 is the next value minus previous value f of x comma y. These are the gradient operators. So based on this, you can represent the two values like this. Just you will get a minus 1 and 1. So this is the one way of gradient operator. This is the second derivative is nothing but minus 1 comma 1. These two are the one dimensional mask used to implement the by the above two equations. So that means if you want to represent the same thing in the representation point of view, just you have to take the corresponding representation. Okay, so y of x x x minus 1 is this one, x of x plus 1, this is the direction. So because of why? Because it is a coefficient, right? So this coefficient value is equal to here. Suppose if you are taking the x direction means that this direction. Okay, for y direction this is the direction. So this is the present pixel means that f of x comma y is the present pixel. F of x plus 1 is equal to next one. So f of x comma y, f of x plus 1, f of x comma y location. So here also same thing. F of x plus 1 means the next location. That is nothing but y. F this is the starting. This is the next one. So that's why these are the gradient operators for the corresponding images. So like this, so many operators are there. Based on that one, you have to represent so many filters, Sobel filters, like pre-bit filters are there. So for our convenient point of view, I have to represent some of the notations. That is equal gx is equal to dou f by dou x is equal to z9 minus z5. So these are the sum of the filter by taking the consideration of a figure. 10.4 means that suppose if you are taking the mass consisting of the elements, like in these elements, like this is a starting value z1, right here, just I will change the color, z1, z2, z3, z4, z5, z6, z7, z8, z9. Suppose if you are finding the corresponding values in this, based on this one, you will get a lot of information where gx is equal to dou f by. So these are the different directions. So this is a reference pixel z5, z8 minus z5, this is the x direction. This is a z8 minus z6 is the diagonal direction. So these are the different ways you have to find out the corresponding pixel values. So for our robots also propose the 2x2 image gradients of a 2x2. Just I will represent the robots cross gradients. This is the robots cross gradients. Robots cross gradients proposes this one. So in this case also -1, 0, 0, -1. Here 0, -1, +1, 0. This is a robot kernel point of view. At the same time, Prewitt Sobel also proposes the two different masks, like that is also similar to this one. Just I will write these are the Prewitt operators for edge detection. So it is also 3x2 matrix. Just I will take the, so here -1, -1, -1, 0, 0, and 1, 1. This is for detecting the horizontal direction. So this is for detecting the vertical direction. So that means the central values are obviously different from the neighboring values. So this for horizontal, this is for vertical direction. So these are generally called as a Prewitt operators. Prewitt operators also use it for edge detection point of view. Next, move on to the Sobel operators. Sobel operators also use it to identify the locations of the corresponding horizontal and vertical edges. So it is also a 3x2 matrix. It consisting of the values of, okay, so that values are -1, -2, -1. So 0, 0, 0, 1, 2, 1. At the same time, the corresponding another filter for detecting the vertical lines, -2, -1, 0, 0, 0, 1, 2, 1. These filters are generally called as a Sobel filters. Sobel operators. These are the different operators. These operators can be taken from different equations, like just I have to mention the some of the just I will write the basic equations how we are going to represent. So for that purpose I have to represent the gx is equal for dou f by dou x, that is equal to z7 plus z8 plus z9 minus z1 plus z2 plus Z3. This equation and 10.2, this is another equation for getting the Prewitt operators. So this is a Prewitt operator equation. So for the same time y direction, dou f by dou y for Prewitt operator is equal to same thing. So Z3 is the highest value, Z6 plus Z9 minus the remaining values of first column, Z1 plus Z4 plus Z7. These are the two equations for getting the Prewitt operators. Okay, so at the same time for getting the Sobel operators also, we have two equations, that is nothing but Gx is equal to dou f by dou x, that value is equal to Z7 plus 2Z8 plus Z9 minus Z1 plus 2Z2 Z3. So this is for x direction. At the same time for Gy is equal to G dou f by dou y, that is equal to for y direction. Y direction columns means Z3 plus 2Z6 plus Z9 minus Z1 plus 2Z4 plus Z7. So these filters are used for, these equations are based on these equations, you can write the Sobel filters in the previous Sobel operators. So based on this equation, just you have to compare these equations for Prewitt. By substituting the corresponding coefficients in these two equations, you can get the Sobel filters as well as Prewitt operators. So by these coefficients values also equal to same coefficients of the corresponding two equations. Okay. Now at the same time, these Sobel and Prewitt operators also can use it for identifying the diagonal elements also. So for diagonal elements point of view, we can use the Prewitt filter as well as a Sobel filter. It is also 3x2 matrix. Just I have to give the values. So for directional elements 0, just I will change the color. It is not that much of good. So 0, 0. So only diagonal elements are different compared to the surrounding elements. So 1, minus 1, minus 1, minus 1 for one direction. So this is for another direction. So 0, 0, 0 plus minus 1, 1, 1, 1. This is a Prewitt filter. Prewitt for diagonals. At the same time, Sobel filter is also available for detecting the diagonal elements. It is also a 3x2 matrix. It consisting of the different values like Prewitt filter 0, 0, 0, 1, 2, 1. So minus 1, minus 2, minus 1. So one direction. Minus 2, minus 1, 0, 0, 0, minus 1, 1, 2, 1. This is for Sobel for diagonal. These are the different filters are available for finding the corresponding values in the gradients. At the same time, finally, m of x comma y magnitude value is approximately equal to g of x plus g of y magnitude. By adding the g of x and g of y, you can get the corresponding two values. So, thank you for watching GMK tutorial guys. Thank you.